thank you so much for being here after lunch. I know that is like the after lunch talks should be really good because otherwise you guys will fall asleep. I will try my best to make you guys like paying attention to the presentation, okay? And thank you so much for coming to a talk that is talking about testing, because we know that as developers, most of the time testing is boring, right? And sometimes we try to skip it, but it's not that smart to do so. My name is Elias, or Elias. I'm a principal engineer. I'm from Brazil, but nowadays I live in the Netherlands. I'm one of the Java champions, Oracle Ace for Java, and I work in the Java Magazine Netherlands edition. And a fun thing about it is that we sent the printed magazine there. We do have the digital format, but for everyone we send like the real magazine, so you can smell, can feel it, and you can just put aside and read in your Kindle later. No, I'm kidding. But it's a nice feeling, right? Nowadays everything is digital. It's a nice feeling to receive the magazine itself. Cool. You guys can find me exactly my Elias Nogueira in everything: Twitter, LinkedIn, Blue Sky, in OnlyFans, whatever you guys will find me. And I normally make this joke, no one laughs, right? So cut this from the video, please. Okay, the talk will be focused on the testing, but there is kind of organization for that. First, I will talk about the problem, then how to solve this problem. I will show you code examples, and then I will show you the takeaways. For me, if you guys have any question during the talk, for me it's fine, but we have some time later in the end of the talk. So, just to give you a context, this is exactly what I'm working right now today. So, we do have, the company I work for, digital platforms, and we do basically banking. So we have onboarding, lending, business, assist and engage. I'm working in the middle of that, like digital banking. And in the full platforms, basically, the full platform is APIs. We do have common APIs, enterprise integrations, a lot of different stuff. And through the APIs, of course, we do also provide the front ends, web or mobile. So basically what we do, in general, we are a banking system where if you guys on the right side want to open a new bank, you guys can buy all the services from us except the core bank system. That is normally we develop or we buy from someone else. And then the full other platform we can deliver out of the box. And like in weeks, you can have a bank operating normally. So this is basically what we do. We do, of course, have these connections below with the core bank system, fintech partners, open banking, which we don't control, which just open for integrations. All right? So it's basically the business view. And zooming in the digital banking, we have a lot, but a lot of different APIs. Everything you can think about banking, we do have as APIs for retail customer banking, like normal banks or retail banks. So you guys will see, for example, approvals. That is not a common thing that when we are in a bank and like, okay, I want to make a transaction, pay my credit card, something like this, but like approvals is more business, so it's a different flow, but it's still banking. Those are only few APIs that we do have. And in those few APIs we do have, I'm doing in the payments. And this is not an entirely payments part that we do have. This is a super fine view about it. I want to explain to you this process more or less because now this will be the talk in the parts of technical code examples, okay? So payments, actually, it's not only one service, we know that. So, and not only 3 services in Blues, we have way more, but just to give an explanation. We call internally a payment order, which is basically the orchestration about everything when we do make a payment. Then we have some options. We can configure, for example, if the payment is an ACH or it's a SEPA or if a different kind of payments, we can configure that. We have batch process as well for payments. And every time I make a payment, the payment system emits an event for different purpose. Here I'm explaining that, okay, I will submit an event for an event listener, where the audit service will consume that and we just get everything, all the metadata that is necessary to just keeping track about all the steps and everything we are doing about it. When I'm doing a payment, if it's like kind of retail banking, I have an approval process. In front of the approval process, I have limits. And if there's some limit set, for example, batch payments, I cannot like approve a batch payment that in total the batch is more than 1 million. So there are a lot of kind of business rules for that. And for batches, for example, there is business calendar. I cannot process the batch and make the batch payment if it's like on holidays. It's a public holiday, for example. Like we have those restrictions. And for this full platform, we have like specific integrations with the core bank system, with different ones, which is more layer of testing. So zooming in only payments, which is only a group of microservices we have a lot of things to test. And it's complex. And like we can talk the entire talk about how we can do in terms of testing here. But what are we gonna do in terms of testing? Is those challenges. The most, let's say, challenging ones are one, testing with the real dependencies. Why is that? If I'm just focusing on payments, I will come back there. Everything that is not on blue, it's a hard dependence for me, right? So I need to figure out a way to test that. Support multiple databases. As we ship software to customers, customers can have different requirements for different database. So it's a challenge as well, how I can do the test in everything, like in all the possible different databases that I can support. Then mock dependencies. Of course, I need to test with the real dependencies, but like in lower levels, I should run through mocks, right? Just to speed up my process. At some point, I will run through real dependencies, but it's also a challenge. Testing asynchronous requests. Every time that I send a topic or send an event into a service, I need to test that, if it's there, if it was consumed, if the proper service consumed that. And API governance, because one team, for example, payments, are getting, at least in this list of 1, 2, 3, 4, 5, 6 different services, there are integrations that are different APIs. And we should have a governance on that. And we can talk about more challenges, but I will focus technically in only 3. Support multiple databases, mock dependencies, and test asynchronous events, okay? So to start, the coding example. I have a payment system, super simple one. What I'm going to do with this payment system is that I have a payment request as like someone, like you get a beer from here, for example, and then you need to pay for that beer. So the payment request is, okay, you have a POS, like to pay, and you get your card and you pay. So I have like kind of simulating a transaction for that. And for that transaction, when I do this transaction, I will check an anti-fraud system with a third-party one, and then I will also emit like some topics and events for this audit service, just to get all the things that I'm doing. If I have a fraud, if I'm just making the payment, if I have error during the transactions, whatever, this is what I'm going to do. The code example is super simple and silly, and the main goal is not like creating the best system ever, but just giving you the idea of how we can do those stuff, okay? So don't judge me about my code. It will be super simple, so if anything's there, but it will be like most focused on these 3 challenges. So one of the problems we do have when we need to support multiple databases is because like we need to support those, and then becomes complex, and in different ways. So we know nowadays that modern systems must support different databases. And nowadays I'm not seeing basically any company that says, hey, I only support this. In terms of like running infrastructure, yes, but like when we have some redundancies, like some plan B, we can route to another database, even in a different provider. When you need to test that, of course, your service will have a database. Your microservice will have that. So integrations tests, normally when we develop, we run in memory because it's faster. But then you don't get a fraction of possible errors that you can have in a real database. So it's a problem. It's a real problem running into embedded database. And even though I'm creating a strategy to run it through multiple databases, if I think about running it sequentially, in a CI or even in my local machine, whatever, I'm like wasting too much time because it will be exponentially more time when I need to cover more databases. And that is this real common problem of in-memory database doesn't show any kind of real problem with, like, I don't know, MySQL versus Oracle when you have different types. And like when we need to implement that, a lot of people try to do manually, and it's a totally bad thing. We have a lot of, nowadays we have a lot of different tools to help us out, but still I see some people, okay, I need to support multiple databases. They do a lot of manual steps to support that, even during testing process. It's really bad. How we can solve it? Creating a parallel strategy to run this database and supporting multiple databases in the application. Cool? Now, what am I going to do? For example, my microservice now, I know that I need to support at least 3 databases, MySQL, MS SQL, and Oracle. And I will show how to do that. I will exclude Oracle because, yeah, if I run Oracle here, not in a cloud instance, it will be a little bit like delayed. It will take some time. And I want to show first now the application running to the in-memory database, how we can switch to a normal database, and then I will show you how we can parallelize that, okay? Cool, so this is my ID. You guys are seeing it nicely, cool. And I want this, and I want So first thing, by the way, sorry guys, this will be basically Java, but I will try, if you're not Java developer, I will explain in a super nice way that, okay, Java is easy to understand, okay? If I can understand, you guys can understand it. So I have, in my application, the Spring Boot application. As everyone do, I have an in-memory database with H2. It's kind of default, right? And it works really nicely. And of course, I have like the driver specifically in an H2 driver, and my dialect for Hibernate to manage everything, it's also H2. Because there are some specifics with different implementations of databases, of course, different vendors. And I have my integration test. I will just comment this out. I have supersede integration tests here, guys, where I'm just like creating a payment, saving it, try to create a request for that, and then I just, okay, did this request succeed? Can I see those items in the database when I, not in the database, sorry, but as soon as I save it in the database and I make a request, like a get anything, can I see the same data there? Super normal test to do, easy one, and should fail as well. I want to do something like to save all, or something to find all, something to fail. I have a different tests. If I run all those tests, they run okay. And fast, because it's a SQL is a in-memory one, so like 300 milliseconds. Everything here will be H2, right? Cool. What we should do, the first step, switch to a real database. And my advice, of course, is like switch to the one that is the main one or the full one in your context. If it's MySQL, it's MySQL. If it's Oracle, whatever. How we can do that in a simple ways? Whoops. Can you see this like blue icon? It's blue, green, I don't know, like blue, right? Testcontainers. Is anyone here that doesn't know what is Testcontainer or never heard about it? No? 2? Cool, fine, perfect. Testcontainer is a container that they provide containers for different applications, and they can actually mimic the real dependency. What I will do here, instead of installing MySQL in my machine and running it in my machine, or create an instance in the cloud and connect in the cloud, I use through a container. And what Testcontainer does, through Java code or any programming language that they support, I can just like write a few lines, say, hey, I want a container for MySQL. Then start it. You don't need to say that, but like as soon as you have this instance, it will start up the container, initialize it, and you have the database. You can make the connection directly to the database, and then you have a database. Like every time you run the application, the Docker will start that instance. You have it ready. You run your test. As soon as it ends, it kills that container, and it does over and over again. So it removes the real dependency you need to have for, like, not real dependencies, but hard dependencies about databases. How I can do it here? Super simple. For Java meetings, and using Maven, Testcontainers dependency, and I really need the real dependency from that database. That is a specific one all the time. And of course, I need the connector to make sure my application can connect to that database. Super simple, right? I think most of you guys have done this. And then what I need to have as well, and I create a profile here called test. I'm saying, hey, my JDBC is TC, test containers. So I'm leaving all the responsibility for this to test containers. And this test container is on MySQL. It's on this version. And my database is called payments. Then I have my driver, my dialect set to MySQL. Simple like that. And then this is a test profile. When I come back to my test and now test, Spring will do some magic. Do you guys know that, like that meme, like magic? No? Okay. Next time I will put in my slides. It will look at that application test. We will load, okay, database is test containers MySQL. And test containers will initialize that database. My integration test will save and will do all the stuff on MySQL, not on the H2. But Elias, I don't trust you. I will run the test again. And if you see it's taking a little bit more time and say, hey, test containers, MySQL, creating container, starting the container, doing a lot of stuff, and then, boom, test executed. Remember the H2 one? It was almost 300 milliseconds, right? For the test. Of course, there is this startup time for the container. But as soon as the container starts, like basically the test execution, total execution time doesn't change. Because it's the same thing. It doesn't change because of the database. But now I'm using a real database behind the scenes. Cool. So again, MySQL. And I can see that MySQL is here and it's being initialized. And then I can run, like it's running the test and doing all those different things here. Cool. But then I need to support multiple databases, right? I have one right now for testing. How to support multiple ones? The first thing we need to do, in terms of Spring at least, we should have different profiles for different databases. So you guys can see, yeah. So I have MySQL, MS SQL, and I have still H2. So just the difference about MS SQL now, from test containers perspective, in my configuration, my application is that, okay, test containers, SQL Server, this is the version, this is my database, and the dialect for Hibernate. Cool? Cool. Now I have all the supported database, but now I need to create a strategy to run those. And how I can run those differently. One of the possible things we can do in terms of Java and Maven is creating different profiles. So what I have here, I have profiles for MySQL and MS SQL, and I'm saying, hey, Spring profile, activate MySQL or MS SQL. Just for understanding, this will activate that file, application dash the name, and then Spring will load all the configurations from that application YAML, and then I will start up my database as MySQL or MS SQL. But for the test itself, now I have the profile. There is one change in my payments integration test. which is this. Instead of setting the profile, that would be MS SQL, right? I'm saying, hey, I want you to get from what is active, from what we have. The default one is set H2, just to speed up the process. But every time I run like this, if I run the command sending minus profile, minus P, and MS SQL, and I just focusing on that integration test, you guys will see at some point the container will be trying to connect to SQL Server. And then it's starting my database on SQL, and now it's running my tests, and 3 tests successfully run. Cool? Super easy, actually. But now I have another problem. How I can run it, right? I run like one database, I need to run multiple databases. You guys won't run in your local machine. You guys will run it in a CI/CD process, right? In any tool. And one of the things we need to do is instead of running it sequentially, as let's say the integration test will take 3 minutes to run. Then if I run sequentially, it will be at least 90 minutes to get this feedback from CI and say, hey, everything is fine. And if something like my SQL, for some reason, like it's not a variable, if I'm not like focused enough or smart enough, Oracle won't run because, okay, it's failed in the middle of the process. So it's not a good approach. A good approach, of course, it's run it in parallel, where I start all the database at the same time. It's not exactly the same time because it's parallel, you have some delay, but then I can have at least the same amount of time for everything. And through CI/CD process and tools, different tools have different ways to do that. What I will show you here, workflows. It's my GitHub workflow. I'm running it on GitHub as well. And GitHub, in terms of GitHub actions, I can have a step like integration test that depends on my build process first. Of course, first I build the project, right? Then I run my integration tests. And they have a super nice feature called matrix. So I can run things in parallel based on the data I have on a matrix. In my matrix, I have my SQL and my SQL. And then when I run the Maven command, I'm saying, hey, profile, get it from the matrix. Not from the movie, but yeah, from the data from the matrix. Bad joke, I know. Sorry. So I have my GitHub actions here. I have my build and test. I run manually the workflow just to show you that it works. And it's something you guys should do. So it's building. It will take like, I don't know, 10 seconds. And then the integration test job will run with 2 databases. 9 seconds more. More than 10 seconds. Okay. It's Java, right? So it takes some time. Now it's running my integration test in 2 databases in parallel. And you guys see, you guys can figure out that there is not amount, or like there's basically no code at all. It's only few things in my POM XML, creating profiles, duplicating my application profile in Spring, just make sure I have the different databases, and then just setting what I need to focus on. In terms of like parallel execution CI, in GitHub Actions, there's a feature for that. I'm just using that feature. Of course, in other programming languages, in other strategies, you guys might have the same thing. So you guys need to have multiple databases, have a way to start those databases, and the CI/CD will be basically the same, with just like different commands maybe. And for example, MySQL, it's running on MySQL, because if I try to search the logs MS SQL, I can see that the focus is on MS SQL. The container is actually using that. Same thing for MySQL. Cool? Easy. Oh, I already showed. So takeaways for this. Integration tests you guys must run your integration tests in multiple databases if you guys need to cover multiple databases. Or even if you guys need an integration test, cover different dependencies that you're consuming. If you guys support different, I don't know, queue or anything, you guys can do the same approach. Instead of database, just the focus, what you guys should do. Parallel execution is a must nowadays because we want to understand if our tests are failing, if application is reliable enough to make the next step or deploy into production or just waiting for a click to deploy to production. And using containers, specifically with test containers, you guys can use Podman, whatever, it will make you be close to the production using that databases or that dependencies there. The second thing is about third-party systems. So this really creates a fragile dependence between your test and what you need to test, right? Because you don't own that. And then you need, okay, maybe it's online, maybe it's offline, maybe the data has changed. You don't have any control, and this is a hell to manage. And I'm like, for sure you guys are facing or faced this problem before. So, remember that every time that I make something in payments, I will send a topic to Kafka actually, say, hey, there's some metadata here, someone will consume this, okay? But what I will try to mimic is the consumption that I will show later. But the problem with this, like, normally we do mocks internally through the integration test, right? In terms of like Java Spring, like mock MVC, we can use Mockito, whatever, we mock that dependency. But sometimes we can also use a sandbox QA environment for this third party. Both, from my experiences, are not that good. The mocks that we use in the teams are nice, of course, because they can run, but imagine that, like anti-fraud system. I don't have only payments, one of my teams using it. I have the entire company use the same service. And then the developers must implement basically the same mock in the code in 23 teams, different teams. And then if there's one change, 23 teams needs to change everything. And if I had another change, 23 teams needs to do over and over again. So it's a good approach, of course, but when this third-party system is being used widely in your company, we need to have another way. So we cannot trust, right, in your third-party systems. So we need to create something better. The tests that rely on them will be flaky and slow, or one or another or both. And local mocks make it consistent, but for one single team. It's limited for the team, while other teams need to use that as well. So how we can fix it? With some things really cool in the market called service virtualization. And we do this with WireMock and also with Docker. So what is service virtualization? And then I will make a pause to read everything. No, sorry. But like service virtualization basically is simulate behaviors for external systems instead of relying on real services. So teams can use like lightweight standings that mimics the real one's behavior. Okay, this is super beautiful, right? ChatGPT actually generated this for me. But like this image is better. Imagine that this service virtualization is your third-party system. And then in the service virtualization way, this service virtualization will apply you as the third-party system. And then you can have all the teams connect to that with one source of truth about mocks. And as it mocks, and nowadays we deploy everything on Kubernetes, or at least using Docker for that, you can easily create a Docker container like with WireMock or with any other kind of provider. And you can run it locally in your Docker container, or you can deploy in a Kubernetes infrastructure, make it available for everyone connects there. Easy. Or you just deploy a Docker image, put somewhere, they pull the Docker image, they store it locally, and they can run all the tests mimicking that mock. And it's different from the coding mock because you're centralizing the mock. If you need a fix that should be like, will impact everyone, you just do once there, and then everyone will have this fix. Cool? So service virtualization will replace real calls. And when you use WireMock, it's super simple to do that. We can share the mocks across the teams, and it enables us for reliable, repeatable integration tests, and without like using the sandbox third-party systems. Cool. So what I will do, this anti-fraud fraud check system, I will create a container around it, and I should know the OpenAPI spec, the specs for that, for the API, and then I can, of course, build based on my conditions for tests. I can build what I need to execute. How we can do that? So let me show. Cool. So I have here one test that is a normal one that I'm saying that I don't recommend. I'm using Mockito here. And then what I'm doing, I have a setup creating a payment, and I'm just saying, hey, of course, as a third-party system needs to have a configuration to hit the normal endpoint for that. I'm saying, hey, just like when I need to get the URL, like just create some endpoint, some API key. And then what I'm doing here, I'm saying, hey, I want a not like a valid payment with no fraud detected. And I'm saying, hey, exchanges, like when I receive any string, and from this request is a get with anything inside, it should be equals with that response that is not fraudulent. And then return, okay. And then it's the response for that is fraudulent is false, and the message that will return from that service will be transaction approved after successful fraud check. So I can make that payment. And I have exactly the opposite with transaction flagged as suspicious and is fraudulent true. But this, like, I'm just mimicking the behavior that is not happening. It's not real, right? But it's important to have in our as tests because it makes safer when I do any kind of change in my controller, in my service, whatever. So if we run this, it will run without any problems. But imagine, oops, that I do want to connect to a vendor. And I configure, okay, it's my sandbox QA vendor.com, this specific port and this specific API path, and with X thing. If I try to run this will fail because I don't have connection to the sandbox. And this will be a normal issue sometimes, right? Because you can create a test like this. Of course, it's nice, it's fine. You should have a test like this, but then the third party is out. It cannot connect. I have an exception here that, okay, that's something weird happening, like connection refused. Cannot like unknown hosting. Cool. This happens a lot. How we can fix this actually? Let me just remember if I have the slide. No. So how we can fix this? I can use WireMock in terms of container, but the first thing before the container is that in WireMock we can develop by Java code or by JSON files. I really recommend JSON files. And then for the JSON files you can have the mapping, which is the request that should come in. And then you do another file that you call it files there. That is the response. So what it should respond. So for example, when I have something that is, oh, this is the response. When I want to check a failure, success first. What I'm mapping here, I should have, when I have a request that is get for this API fraud check with query parameters, any amount, any transaction ID with this API key, then reply me 200 and get the content from this file, the success one, which is this one that will return, not this one, sorry. Fraudulent false, transaction approved, blah, blah, blah. Cool? And then I have actually the other one, and I can say, hey, when I want to simulate a fraud, when the amount is this one, and only this one, replied me, fraudulent true, and then it's suspicious. Then you control the behavior with some parameters. When the transaction ID is X, when this has a combination with this transaction ID and this amount. You can do a lot of things, but it needs to define those conditions in terms of testing. It should be connected to your test. Cool? Simple, right? Now what I have here, I just have a Docker image that will show, hey, I'm using WireMock. I have a name for that. I'm exposing the port 8087, and I'm just doing the internal mappings for WireMock. I can run this standalone, but I'm going to say, hey, get my files internally and map to your container in the files directory, and my mappings to your mappings internally, and then I just have the normal entry point here. How it works now? I will run this container through here. Cool, it's running. Just start it. Now I'm in localhost, right? Now that my integration test that runs into a sandbox, I can simply, it's fraud check integration test. I will change this to localhost. The API key is still the same. And now the magic will happen. The tests are running because WireMock is applying instead of like the third-party dependencies. And with WireMock, I can even do like, hey, if the service is not a variable, then you do the routing to WireMock. If the services are variable, just consume the service. So you can like remove or fix the dependency. The only thing is not a drawback. You need to create those kind of mappings based on your tests, based on all your test conditions, because you know how to test that. Then based on a condition like I want a fraud, I need to see that is a fraud. You need to define a condition, okay, this amount specifically in my test, of course not real. Then you have it. Easy, right? And what we do actually there in the company, we do have a mock server, which is a super huge container. You guys saw that it's basically mapping files. So we have like different folders for different third-party dependencies. We have all the mappings. We deploy this in infrastructure. We have offline as well. All the teams can use now without creating true code that's specific, like using Mockito or Mock MVC, whatever. They can actually hit an endpoint. And they can really see those kind of, we can even simulate latency and everything that when we're doing requests. So it's really helpful because when we need to change something, a third-party dependence, we change in the mocks, we deploy, everyone has the latest version, they can use it happily. Cool, takeaways. So now we have like predictable mocks and reliable mocks, right? Creating this Docker approach, this containerization, container blah, 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 something, we can actually distribute this across the teams. And the release process, when you need to run a CI/CD, whatever, it's super stable because now you're actually like removing that instability about third-party, sandbox, keyway, whatever, from someone. And lastly, testing asynchronous events. This is super easy, actually. It seems like really difficult, but it's not, at least in Java. I don't know other programming language because my main is Java. And time is everything. So remember that all the time that I have something in payments, I send an event, a topic, and I use Kafka here. And this topic is there to be consumed for audit, for this audit service. And we'll just get information. We consume this information in Kafka terms, right? If I run a test, there is a high chance of basically 100% the test will fail because there is a delay, right? In the topic. I'm sending something to another tool and I try to consume it in an audit. And hey, it's not there yet because I have the topic in the Kafka and then the application will consume that. And it's a problem, it's a real problem. Or I can fix that. Normally, we fix in a wrong way sometimes. So developers are super smart and sometimes we do a sleep or pulling hacks for that. But if we do a sleep and pulling hacks, maybe the request will be there in like 500 milliseconds, but I'm waiting 2 seconds. So I'm waiting way more time than I should. All those kind of systems based on event queues introduce all the uncertainties because I need to somehow control it. And integration tests will fail because of this delay. How we can make it good and faster and reliable? Synchronize this test. And there's a tool, there's a library, super easy one, super nice one that you can use called Awaitility in Java. And we can create kind of dynamic conditions for that in a smart way. If I need, I can say to Awaitility, hey, wait at least 5 seconds, but if it returns in 300 milliseconds, don't wait the rest. Just proceed, right? Super, super smart. We can avoid fixed timeouts and make the test more resilient, and we can have more realistic behaviors when you're dealing with the situation. So, I will first show you how it works. By the way, I have here a Kafka, and I can say that I can show that I have a lot of messages that like this all the service you consume. Okay, so I have one here. Okay, the payment that has I have a timestamp is created, it's pending. Another one, okay, there is a fraud here, and like that other service, whatever, will consume those topics and just like using in a super nice way. In terms of tests for events, what I have here, I know that this should fail because the event will take too long. And actually I added a hack just to increase a little bit the time. It would take 2 seconds to have the topic ready to be consumed, to consume that, just to simulate the failure. And what I'm doing, basically, hey, producers send the event, and the consumer gets this event, my audit service. I should see that like the event is created, I'm consuming the event already, that the payment ID is the same as the one created, and the timestamp is the same. But if I run this, it will fail right away. Now, and you can see that, okay, we are expecting, here. We are expecting something, but I get an empty array because I don't have this topic yet because it takes a little bit of time, okay? How I can fix it? Really simple. I talk about awaitility, right? There's a lot of ways to use it. Awaitility.await at most duration of 5 seconds. Then I want to until asserted because this is the test. So until I can assert this. But you can use a lot of different conditions and even create a condition, a callable, to create a custom condition that you should wait. For example, I don't know, a database, something more specific in a service, whatever, you can create a custom approach. But I say, hey, until asserted, and then it's a function, and then you basically get this one here inside, and I will remove this, and then, hey. So I send the event, it will take some time, then when I'm consuming it, I'm saying, hey, Awaitility, go there and wait at most, or at least 5 seconds. And it will be pulling. Here it's the default configuration is every half second, but you can increase or decrease it wherever. And as soon as I have that, then I will assert. And when I run actually this one, you see that the test will halt for a while. Here, just now it runs. It's not instantly. You see that like the test is there, kind of running, waiting, and then it runs successfully. How I don't know that it's running successfully? I would just do, and a normal thing to do, guys, while you're testing, don't 100% trust all the information, change some data just to make the test fail. Just like, cool, it's failing because yeah, this. In terms of timestamp, what I do here, I'm getting from the event when I say, hey, I want the instant now. And this will fail because it's different. Like the timestamp will be exactly different because I'm waiting a little bit, at least 2 seconds. Or it goes, sorry, to the queue at least 2 seconds later. So when I run this, and it's still waiting, but it will wait for 5 seconds instead of like it's waiting, it's waiting, it's waiting, it's waiting, and it will fail. Because I don't have that. It's empty. Here. You can see that like tried to do in 5 seconds, but it's not there, and it was pulling. So in a super simple way, actually with basically like a line of code from this library, I can make like a synchronous system works in the perfect way in my integration tests. So now what we can do using Awaitility, actually, like it has this delay to consume the event, but like this library will be pulling until it's there, then I can continue executing the test. I already showed the code. So the takeaways for this one. So asynchronous calls recall resilient assertions, right? And remember, I changed a little bit the code just to show that like it can fail, depending on the data, of course. This tool helps you to wait, but of course not that long. 5 seconds is a lot, but it's just to show you, for you to understand. And like we can actually create realistic tests for that. Most of teams or companies actually are skipping those kind of tests, right? Because sometimes there's like we don't figure out a good way to do that. Now, at least with Java, we can. So to wrap it up, what I have learned now, I showed you 5 different ways, challenge we can have in that architecture, but we learned 3 different ones: how to support multiple databases, how to mock the dependencies is a super nice way, and how to test all the synchronous events. Cool? So guys, thank you for being here, for paying attention, for laughing about my bad jokes. This QR code goes to a page on my GitHub profile with the link for the talk, for the coding examples as well. If you guys want to, I share a lot of content about quality engineering in my social networks. You can follow me there. Thank you so much.
Hi,
cool.
Thanks
Hi.
for the great talk. Actually, 2 questions. One, the example that you showed about having a centralized mock server for a third party, in reality, that third party can still change their interface?
Yeah.
Right. So how would you prevent that? Have you looked into pack testing or contract testing as well?
Contract testing, mostly, yeah. So just like what we do as well, like just make sure we can like know when it changes and it's breaking the contract. We must have contract tests just checking, okay? Is everything still fine from that third-party dependence, or even internal dependence, right? If everything is fine, I know that everything is fine. If it breaks the contract, hey, my mocks should change, right? And as soon as possible, I need to change. I must change the mocks. But you can have different approaches. I don't know if the third party will send you a message, say, hey, the next month you do a breaking change and then you change. But like contract testing is one of the best ways to do that.
On a similar line as him, because I was going to ask something about the mocks as well, as many times our third-party services that we React are in fact internal services in our own company, just managed by other teams, etc. No, and so when you create an internal API, do you also provide mocks or stuff like that so other teams can use that, or?
Yeah, for example, in my application nowadays, these yellow ones are mocks if I don't control them. For example, I control payment integration, cool, but I don't control, like this I control everything, but I would have a mock for integration that I don't control, this becomes a mock. And even for the teams, my teams, I have payment integration. I should provide this as a mock for others in this mock server, so they can consume as well. And everything, of course, this payment integration has an OpenAPI spec because it's a kind of connection, and we build all these mocks through WireMocks based on OpenAPI specs. Thank you for the question. Cool. Yep. All right. Guys, thank you so much again. I will be around here. If you guys have more questions later, I will be super happy to exchange some knowledge.